All right, here is our video guide for the Notes 2.7 Nonlinear Inequalities. Okay, we're only going to try to hit a few examples here because the problems take a little bit. So if you want to see more examples of it, just let me know and I will make a different video. But for the sake of keeping it somewhat short, I'm only going to hit some of the key examples. Okay, so nonlinear inequalities, we've done stuff like this before a little bit. What it's going to be mostly is finding our x-intercepts or the zeros of our function and then testing points around it to see what our answer really is. Okay, that'll make more sense once we do the first problem. So let's do that. Here we have our first, this is a quadratic nonlinear inequality here, and we're going to solve this left side for our x-intercepts. And so we really have to find x squared minus x minus 6 equal to 0. Now we look at this and we say it's got to multiply to be -6 and it's got to add up to be -1. And the two numbers that do that for me is -3 and a +2. And so this becomes x minus 3, x plus 2 equaling 0. And I'm using equals right now. I'm going to go back to the less than sign at the end, okay? And so my two x-intercepts here are x equals 3 and x equals -2. And those are going to be my test points, okay? So what I'm going to do here is I'm going to create a table. It's going to have domains, and then we're going to pick test points inside those domains. And then we're going to see if in that domain it's all positive or if it's all negative, because if you go through the notes, it talks about how in those test intervals it can only be all positive or all negative in between our test points or in between our x-intercepts. And so what that table looks like is you have your domain, you have the number you're going to choose to test, and you have whether it's positive or negative. Okay? My first domain here, and I'm going to be specific, is going to have to be from -infinity to -2. Okay? And I'm using a parentheses here on -2 because I am talking strictly less than. Okay? Strictly less than, I'm using that parentheses. Okay? So I choose another test interval, and that's going to be from -2 to +3. And then my last test interval is going to be from 3 to infinity. Again, I'm using all parentheses here because we are talking about strictly less than. Okay? So a good test interval or a good number to test in our first test interval would be -3. A good number to test in our second one would be 0 because it's between -2 and 3 and it's an easy number. And then the last one could be 4. Okay? Now I'm going to test each one of them in my original equation. So -3 squared is 9. 9 minus a -3, well, that's like 9 plus 3. That's 12. 12 minus 6, that's 6. And I'm just worried that that's a +6. I don't really care that it was 6. I care that it's a +6. Okay? The next one is 0. I plug in 0. I get 0 minus 6. That's a -6, and so that's a negative. And then I have the last one with 4. 4 squared is 16. 16 minus 4 is 12. 12 minus 6 is 6, and that's a +6. Okay, and so those are my answers here, and what we want are the answers for everything that's going to give you less than 0. Okay, well, the only one that's going to get you less than 0 is the negative one, which is my middle one, and so we say the answer is just this middle interval. Okay, just the middle interval. So my answer is the interval -2 to +3, and if we look at the graph right here, it confirms it. Okay. Everything to the left is positive, so -infinity to -2, that's all positive. Everything to the right of 3 is all positive, and the only thing that's negative or less than 0 is that middle interval. Okay? Now on to the second one. We have a little bit more of a challenging one. We have now 2x cubed minus 3x squared minus 32x plus 48 is greater than 0. All I did was add over my 48. I'm going to group these. This is something I said in class, but I'm going to group these. It's not something you often see, so don't worry if you don't really understand the grouping factoring part of this. It's more or less just to show another example of testing intervals and critical or key points here. Okay? So I group them like this and like this. I can pull out an x squared here, and that leaves me with x minus 3. I can pull out a 16 here, a negative 16 here, and that leaves me with 2x minus 3 as well, and that's exactly what we want. And so I have x squared minus 16 is one of them. The other one is x minus 3. Sorry, yes, that's right. I gotta have a 2x here. So it's 2x minus 3, my bad. And that's all greater than 0. This breaks down a little bit more into x plus 4, x minus 4, and 2x minus 3. Still greater than 0. And so I have 3 x-intercepts here, or 3 key points. I have x equals negative 4, I have x equals positive 4, and I have x equals 3 over 2. So when I set up my table, I'm going to have now 4 testing points, okay? Or test intervals, excuse me. So I have domain, I have the number I'm going to use, and I have whether it's going to be positive or negative. My first one is going to be negative infinity. And again, this is strictly greater than here. Strictly greater than, so I'm going to have to use all parentheses. Negative infinity to negative 4. I then have negative 4 to 3 over 2. I then have 3 over 2 to positive 4. And then I have 4 to infinity. Those are my 4 test intervals. Okay? Because I had 3 key points, I have 4 test intervals. Okay? Choosing points within each one of them. The best one here is negative 5. The next one here could be 0 because that's between negative 4 and 3 over 2. The next one here I could choose 2 because that's in between that or somewhere in that interval. And then the last one would be 5 because again it's somewhere in that interval. Now I am going to use, instead of using my original equation because I don't want to use any cubic stuff, I'm just going to use this here to test my points. Okay, so I plug in negative 5. Plugging in negative 5, this is going to be a negative, this is going to be negative, and this is going to be negative, which means 3 negatives getting multiplied together, we're going to end with a negative. Okay? When I plug in 0, 0 plus 4, that's positive. 0 plus a negative 4, that's negative. 0 minus 3, that's a negative. So a positive times a negative, that makes it negative, times another negative, that makes it positive again. Plugging in 2, I have a positive, I have a negative, and I have a positive. And so that's going to be positive times negative is going to be negative. A negative times a positive is going to stay negative. Okay? When I plug in 5, I have a positive, I have a positive, and I have a positive. And so that's going to be positive. Now I want all the intervals that make this greater than 0, or all the intervals that are positive, and so I choose this one here, and I choose this one here. And so my answer, I have 2 intervals, so on this one, my answer is negative 4 to 2 over 3, sorry, 3 over 2, screwed that up. And I have 4, positive 4 to infinity. Okay, and those are my 2 answers here. Okay, there's only 2 more examples I'm going to do. I am going to show you one here, what happens when we get no solution. Okay, and so here we have, in C, we have it has to multiply to be 5, add up to be 3. Okay, well, there's no 2 numbers that do that, so that means this is quadratic formula. And we have negative b plus or minus the square root of b squared, which 3 squared is 9, minus 4 times my a, which is 1, times my c, which is 5. All over 2a, which is just going to be 2. And hopefully you already see that this is going to fail, because I have 9 minus 20, so this is going to be negative 3 plus or minus the square root of negative 11, all over 2, which tells me for x-intercepts, or zeros I could say, there is no solution. So when we set up our table, we have no key points to use. We have domain, we have a number to choose, and we have our positive or negative. Well, our domain, we have no testing points, and so our domain is just going to be negative infinity to positive infinity. Our test point then could be 0, because that's somewhere in between there. And when I plug it in, I get 0 plus 5, and that's positive. and I'm looking for everything that is greater than 0. Sorry, I want to erase that. I'm looking for everything that is less than 0, and since all of these are positive, that means everything in here is going to be greater than 0, so my answer really has no solution because there's no interval that works. Okay? Now it is possible to have no solution and have an answer, because imagine right here that this is greater than. Well, then this works because everything is greater than. Everything is greater than. So with a sign change there, you could have said that the interval or the answer actually would have been negative infinity to positive infinity. But because we are actually working with not greater than, we're working with less than, we have to just say that we have no solution because nothing down here is negative. Okay? Now one more problem here. Right here, we have the same kind of thing. We have 2x minus 7 over x minus 5. We're going to subtract over the 3. So that's a negative 3, and that's going to be less than or equal to 0. Common denominators here, that's going to tell me that this is 2x minus 7 minus a 3x minus 15 all over x minus 5. Greater than or equal to 0. Combining my like terms, this becomes negative x minus a negative 15, that's going to be like adding 15, so this becomes positive 8 all over x minus 5. Now the one thing I need to note here, because nothing else is going to change, and so I'm going to end the video after I explain this. Nothing else is going to change about my table that I set up with my domain and my test numbers and my plus or minus. Nothing's going to change there. We just got to make sure that our x values come from the numerator and the denominator. So we set our numerator and denominator equal to 0 to find out what x values we should use. So I have negative x plus 8 equals 0, and I have x minus 5 equaling 0. And when I solve for both of them, I get x equals a positive 8, and I get x equals a positive 5, and then I can set up my table. Domain, number, plus or minus. My domain is going to be negative infinity to 5, and this time I'm going to use a closed bracket, okay? And I'm using a closed bracket because we have a less than or equal to, and so we got to use closed brackets on our numbers, okay? The next interval would be bracket 5 to 8, and then the last one would be 8 to infinity, okay? The first test number you could use is 0, you could use 6 here, and then you could use 9 here, okay? You test them, and you'll see which ones come out positive, which ones come out negative, and we're looking for ones that are going to be negative because this is a less than or equal to, okay? Again, I go through this kind of quickly because a lot of these problems can take a long time. So if you want one problem really broken down because this was too fast, just let me know. I'll happily make one. And then make sure I updated the homework here at the end. This is the updated homework. Please only do these 4 problems and the practice test for the test that will be on Tuesday of next week. Okay? Again, any other questions, please let me know. I'm happy to answer them.